It's going to be 50 minutes, about 30 minutes for, maybe 25 minutes for my presentation, and then about 25 minutes for questions. I hope you will have questions. It's about microservices, about chatbots, about all that stuff. I'm a CTO of a small software company. I'm myself writing code, and I created some chatbots in myself in Java. So I'm going to basically speak from my practical experience today. That's what's going to be about. So I'm going to say that UI, the user interface, basically sucks, and just use chatbots instead. And I will try to explain why and what's the difference and why UI is a problem, potential problem, and chatbots is the future. I think it is a future for cloud architecture and microservices architecture. So that's basically the main message of the presentation. I'll try to use UML, but don't just pay too much attention to these complex diagrams. I'll try to make them as simple as possible. So this is the user who is talking to some service. So let's say we have some microservice which does something for us and manages some database and operates with some assets. I don't know what it is, like I think you like, for example, the continuous integration service. So you basically configure it somehow, it controls the number of servers, it controls some database, and you talk to the service or the API. Like this is the traditional way of what is microservice. It's an API, you make RESTful requests, and the service replies, and managing the assets. And there's a user here. And the user is like a real human who has to talk to this microservice, and has to control what's going on with this service. So give some instructions, give some commands, get some responses, and basically control what's happening with the microservice. This is a traditional way of how it's designed. For example, Travis, which is probably you know about that, the Travis CI, which is a continuous integration system, it's designed exactly that way. So this is the architecture of Travis. So they have the API, they have me as a user, I give instructions, and they control, they have some database behind the interface, and they have some assets, many servers, where all this stuff is happening. And this sucks. That's my message. And this is the alternative. Again, a complex diagram that I'm trying to explain. And this is what I'm suggesting instead. My suggestion is this. I'm still a user, and it's still a service. The service still manages database and assets. Assets, I mean servers, like machines or something like that. So we still have the service, and we still have the user. But we don't talk to each other anymore. So I'm not connecting to the service directly. I don't have any UI. I cannot go there, I cannot log in, I cannot open my panel, I cannot give instructions through the UI. All I can do is that I can go somewhere on some hub, some message hub, for example GitHub, and post my messages there. And the service will understand my messages and respond there as well. So I post a command, and the service picks this command up and says something back. Like I'm saying, hey, Travis, for example, build something for me, or, I don't know, start a server and build something on the server. And the service understands my request and sends me a response. So basically, this is how it looked before. So this is me, this is the service, we talk directly. And this is how it looks now. So there is no direct connection between me and the service. So we are completely decoupled. So there is some space, some hub, communication hub, where we talk to each other. But we never talk directly. I don't have a UI, I don't have a panel where I can use my mouse and open something and then click the button and see the result. So we are decoupled. This is called chatbot, basically. So the service becomes a chatbot. So it acts, for example, it goes to GitHub and it talks to you on GitHub. But you never talk to it directly. You always talk through the messaging platform, through the messaging hub. Did I manage to explain it, the idea, basically? And now I will go to why it's bad. But did I explain how it works? So it's like it could be IRC or Slack or Skype or something. So it's a discussion place where you say something to the bot and the bot replies to you. Like on IRC or anywhere. Just some discussion, like in Slack, for example. On Slack it's very popular. So now we have 6 benefits. That's what I'm going to talk to you mostly about. So there's six things which actually makes this approach way more attractive to us programmers. Not only to users, but mostly to designers, to architects of this system. Number one, first of all, no need to be fast anymore. Because the service doesn't need to be fast. You don't need to make it really like bullet fast. Because if it's a UI, if it's a front end, if it's user interface, then it has to be extremely fast. Otherwise, the user will not like it. So you want to click the button and you want to immediately get the response. You want like response in 100 milliseconds. If it's 2 seconds or 3 seconds, you just don't like this service. You're not going to use it anymore. If there is a chat, if there is a Slack between us, for example, or GitHub or IRC, then I'm not expecting the chatbot to be so fast. 3 seconds, 5 seconds, 10 seconds for response, it's acceptable. You say something in the chat, you wait for 10 seconds, you get a response, it's pretty good, right? Because in a normal human-to-human communication, you don't expect another person to be like half a second fast. It's okay for you to wait for 5 seconds. It's good for us, for the architects, because we can design the system really slow. We don't really care about performance anymore. It can be slow, which is good, right? So we can control the servers, database. We don't really care about performance, which is good for the architecture. That's first thing. I'm speaking of practical experience because I designed one chatbot, a few chatbots, and most of them are slow. I mean, they could be faster, but we're not paying attention to that, not spending time and resources to making them really bullet fast, which is really critical if there will be UI. If you have a UI and it's slow, you have to spend time and efforts and money and everything in order to make it fast. In this case, you don't need that. The benefit number two, you don't need to look cute anymore. Because there is no UI, you don't need to look nice, you don't need to spend your time and efforts for designing it nice. So you don't really care about this HTML, CSS, you don't need designers basically. You just design your service, the microservice, and you focus on the key functionality. You don't focus on the design, on the UI. For example, look at this Travis again, which is again like the kind of microservice and service for continuous integration. They spend a lot of efforts for making it. It does look nice. It does look nice, all these features, buttons, the screens, everything looks cool, but how much time they spend for that? Instead of spending time on making it like fast, better building stuff or using some new features, new technologies for actually doing continuous integration. Instead of spending time on continuous integration, they spend time on making the UI to look good. And this is a typical problem for many web systems, for many web services, when they have many companies who are building that. They have a good team of engineers who can do the back-end stuff and who can actually make the service nice, but they don't have good designers. And the product just doesn't look cute and you can't get to the market. Just because it doesn't look nice. In case of a chatbot, nobody knows how it looks, because all users see is just an answer. So there's a question, like do something for me, and an answer comes back, and it's just a text message. So just no need to look cute anymore, which is an advantage, I think. Well, for me it was, because I'm not a designer. I was designing the chatbot, one of the chatbots, about a year ago, and that was my problem, like how it should look. I'm not a designer, I'm more like a back-end developer. So how much time, where did you get this designer, and how much problems I will have, by designing the UI. So that's the reason number two, I think. The reason number three, the benefit, is that it's easier to scale. Because now, the chatbot is not actually, the microservice is actually not a server anymore, but it's a client. So in this architecture, let me scroll back a little bit and show you this architecture. In this architecture, in the traditional UI, the service is a server for me. So I'm a client and it's a server. So I'm asking, he's giving it to me. In this architecture, look at this. Now the service is actually a client for the hub. So it's not a server anymore. Nobody talks to it. Nobody makes requests to it. It just works like a client from now on. It connects somewhere. It makes requests. And it works like a client. So in this case, I need an HTTP server inside this server. In this case, I need HTTP client. That's a big difference. Being a server and replying to HTTP requests, or being a client who sends requests when I need to send them. It's easier to make multi-threading. It's easier to make to handle the load and everything, because I control what's going on. I know when if I don't have resources, for example, if I'm out of thread, I'm just not making a request. Because I'm in charge now. Because when you're a server, then they come to you and say, I need a response right now. And just you have to do something about it. So it's more difficult to scale because you have to be ready for unpredictable situations. But if you are a client, which is like, there's 3 of them. So for example, I can scale, I can create 3 servers. And 3 of them are talking to the messaging platform. So you just have 3 machines doing exactly the same, talking to the messaging platform, to Slack, for example, and asking, do you have a new message for me? Do you have a new message for me? Okay, you have it. Okay, I'm going to answer it. Okay, I don't have any more time for doing that. Okay, I'll wait. I need more servers. Okay, I'll add 3 more servers. Or I just, shrink down and I have just 1 server. But I'm in charge. I control it, which is way easier to scale. You see the difference, right? Being a server and being a client. So the big difference in this whole approach of chatbots is that a chatbot is always a client, not a server, which completely twists the whole situation upside down. I'm not anymore replying to your requests. We're just talking to some place, which is you post your messages there, and I post my messages there. So this is number 3. The benefit number 3 is way easier to scale. I believe. Well, again, my experience, it's just easier to scale a client than to scale a server. Number 4. In total, it's 6. Mistakes are not so visible. That means basically that when something doesn't work, then the client's not going to see it, in most cases. So that's literally what it is. So if something goes wrong and I, for example, deploy the new version of this chatbot which is broken, then the client will just post a message to the messaging board and say like, hey, do something for me. There's no response. Okay, no response. No big deal. Okay, waiting, minute, 2 minutes. But that's a smaller problem than if you make a request and you get like a page 404 back, or you get some internal server error, something is broken. This is really way more frustrating to the user, instead of just not getting a response. Or you see the difference, right? So if there's a UI, it's a server, and I'm talking to it, I'm expecting it to be beautiful all the time and perfectly responsive. If it's not responding to my request, something goes wrong, I immediately start tweeting about it, I start complaining about it, something is definitely wrong, it's broken. In this case, it's not so visible. I'm just again speaking from practical experience. I have this chatbot, which I'm going to mention in the end, and we have problems like every month probably. Something goes wrong. Some server is like disk space is full, the server is out of memory or something else. Something goes wrong on that side. But these guys, they don't see it. Well, they see it, but it's not really that damaging for them. And sometimes they just don't see it. Sometimes, for example, they keep sending requests and then there are no more requests, but the server is down. So I get an email about that. There's nobody talking to the server now, so it's more or less okay. So my point is that the problems are not as visible if you have a chatbot, comparing to the situation when you have a UI, which is supposed to be really responsive and 100% available and run. So in this case, you don't need this 100% availability, or 99.999. You just need to be, it's easier to hide the mistake, which is good for us, for developers, for the architects. That's number 4. Number 5, everything is traceable, which means that everything you do with this service, you do through the messaging platform. For example, a communication in Slack. So you have a log of everything that happened there. You send a question, you get a response. You send another question, you get a response. You ask, you get a response. So it's basically a communication log, like 2 people are talking or 3 people are talking. So you can always get back and see how and what happened, starting from the beginning of the conversation. Because it's basically a conversation, it's like a mail thread, or it's like a chat log, which you don't have in case of UI. In case of UI, you can design your system so that you can go somewhere and click like log of operations, and then you see what actually was clicked and who clicked that. But that's going to be not so easier to understand and not so convenient for everyone. Comparing to this situation, when I can come back to this log in a few days and see exactly who sent the question to the bot, what the bot did, what the bot replied, and what really happened. So in case of Travis CI, for example, I go to Travis and I click rebuild, or I click like restart my build, or I don't know, build this branch, or rebuild this branch. And then in a few minutes, who knows what actually was clicked, especially if there's a few people working. We just see the results in case of UI. In case of a chatbot, we see the full transaction history of who did what, why, and what happened. And this history may stay there forever. For example, in case of GitHub, if it's a GitHub, you have this issue, the GitHub ticket, where all the conversation is happening. There are messages, messages, messages. So you can see all these messages one by one in some time, and it's still very traceable. This is, I think, a very important benefit of the chatbots. Again, for us, the architects, because you can easily understand what went wrong. If something didn't work, if something was not as you expected, then you can get back to the log and see what exactly happened. That's a benefit number 5. Number 6. It's the last one. It's easy to integrate with other services. And I think this is the most important feature. This is the most important benefit. If we design microservices as chatbots, not as a bunch of websites, but actually as chatbots who are able to talk to some centralized place, then we can integrate these microservices. And they can start talking to each other. Because in case of UI, it's always one client, one UI, I'm asking questions, I'm requesting something, I'm getting some responses, and that's basically it. Nobody else can talk to me anymore. So I'm always a client, it's always a server. But I cannot become a server anymore. So I'm always it's just one client and one big server. But nobody can talk to me. In this case, I can be a client, another client can talk there, another one can talk. So the 4 components can start talking in the same place. And they will not know, and the microservices will not know who is a chatbot and who is a human. See my point? So let's say there's a Travis CI, and let's say this is me. Let's say this is somebody else who is a microservice. So I can say, hey Travis, build something for me. And then that microservice will see my request and say, hey, how about I build it for you, because I'm faster. For example, I'm just making it up. So we 3 of us can talk together. There could be more of them. So that could be the future of microservice architecture in general. Because right now we have this RESTful API, so we have a microservice as some server, still a server, and we need to make an HTTP request there, HTTP request, and we get the HTTP response. This is kind of the past, I think. The future is when the microservice is actually is able to understand our messages in some messaging platform. That's going to be the future. And then we just connect these microservices to some messaging platform, and then we start talking there, and they start talking to each other. And that's going to be, I think, the future of microservices. And how they will talk, what's going to be the language, it's up for us to decide. It could be plain text, it could be JSON, it could be XML, it could be anything. Well, if you want this language to be understandable by humans, then it has to be text or JSON, something like that, maybe XML. Or it could be some binary, it doesn't matter. But the point is that you need to have a central place where they talk. Instead of them be isolated and us talking to them, they have to talk, they have to communicate in a messaging platform. This is, I think, is the future of the microservice architecture. So that's basically 6 benefits. I think I finished. Well, I can try again, but I made my point. Now I'd like to ask you what you think.
What about demo?
What about demo?
Yeah.
Well, we can try, but let's try to answer a few questions and I'll show you the demo. And actually, yeah, if you're interested, this is the system I'm talking about. So this is the because, you know, I can't make this presentation like product-centered, so I explain you what I think is in general the strategy for microservices, but this is the product I'm talking about. So this is a continuous delivery, DevOps, automation service, which actually works just like I explained. So it talks to GitHub, so you can open in any GitHub project. I can show it right now live. So in any GitHub project, you open just a new ticket, and in this ticket you start talking to this guy, and he will respond to you. I'll show you now, but give me more questions and Okay, so more questions. Let's wait for that. Yeah.
A question about talking these services to each other. You mentioned that you vision that the future is about when multiple microservices can talk to each other in the same place.
Yeah.
But what is the difference between SOA, service-oriented architecture, and this thing that you are talking about? What do you think is the main difference?
I think the main difference is here in this diagram. So in case of SOA, we still have a client here who makes requests to the service in this XML form. In case of SOA, and the service is still, like I explained, is still acting like a HTTP server. So it always has to respond, and it's a big server, it's a small client. But if we start to integrate, if we need to integrate multiple services in SOA, then we have to there are too many connections between them. Yeah, they all have to know about each other. So if, for example, there's 3 of them, it's going to be 1, 2, 3, 3 connections, 3 lines. If there are 4 of them, it's going to be how many? No, it's going to be 6. There's going to be 6 connections between them. So the more servers you have, the more lines you will have. But in case of a hub which stays between them, this one, we can add more and more services, and all of them the diagram will look like this. You see? So we just more services, one more service, it's just one line. One more service, just one more line.
But maybe I did not elaborate my question. The people who are talking about SOA, they usually draw exactly the same diagram. And they say that we have our services and we have some service bus or some message bus, whatever bus.
Yeah, if there is a service bus, it's exactly the same. If there is a service bus. But a human cannot talk to the service bus. That's the point. So in case of a service bus, you have everything except this. Everything is the same. Yes, absolutely. You're right. Yeah, the service bus is exactly the same architecture, but without the human. So let me show you the demo. It's ready. So this is the GitHub. It's an open source project. I just opened the ticket. You saw it, right? I just created a new issue. And now I'm saying, router hello. So I just posted a message to the service. Look, it's quite slow, right? I'm not like getting a response right now, so I need some time to wait. Maybe it takes some time, so it's not immediate. Maybe it's down right now. Maybe it doesn't work. But let's hope it works.
Is it push or pull notification? You use them or yourself?
Well, this guy, it connects to GitHub through the API every minute.
So it's polling?
It's polling, yeah, it's polling every minute. Yes.
So a question, how did you create it?
You see?
Yeah.
So it just responded. So it's just a project. It's just saw my message. It watches the entire GitHub. It just controls all the project. That's how GitHub works. So as soon as GitHub sees the name of this guy, it immediately puts this message into the queue, into the line, and then it says, "Hi there, I understand a few simple commands, blah blah blah." Okay, let's try to give some more complex command to the router. Let's say router merge. The merge is a command which you give to the pull request, and you ask, "Could you please merge my pull request?" It doesn't matter what exactly, but let's give this command and see the response. Yeah, it's another command. So I continue to talk. That was my first message, I got a response. That's another message. I'm looking for another response, and I can answer your question.
How did you resolve the problems in maybe interface or constant with client side? So, for example, merge or please do merge. It's different requests.
Yeah, good question. Well, in this case, this interface is quite simple. So if there is a word merge, and it just says, okay, good, it's a good message for me. You can say, please merge please, could you please merge for me? It doesn't matter, as long as the word merge is there. So it's a very primitive interface in terms of text. Yeah. You can see it again. We just posted this message, and I got a response. It says to me, it's an issue. It's not a pull request. I cannot merge. So it's quite simple, quite simple interaction with the microservice. But it's through not a panel. You see, I don't have any UI. I don't have any panel. I don't have any buttons there. So how easier it is to design this thing instead of making the full UI. You can imagine that this one is way easier because this router, this server, is working like a client. So once a minute, it connects to GitHub, it makes a request and says, what's new you have for me? You have some new requests for me, it gets the next one, it parses it, and puts the request, and posts the response. Yeah.
But the biggest problem here, I see that how you specify the content. How do you know which comments you can say, what you can say? Also, how do you serialization of the data that you need to send to this microservice?
Yeah, well, it depends on the microservice. Depends in this case, in this particular case, it's quite primitive, and I just created a simple help page. So when you say router hello, it posts. Maybe you don't see it from there, but it posts. It says this page explains the commands. So you just click there, and you go to some web page, static web page, which explains what commands I understand. So definitely there has to be some language, some primitive, simple language of interaction. In this case, I just created this simple language of a few commands. Yeah, question there.
And what if you type router, please do not merge?
It's gonna merge as well. Yeah.
The handle state transitions in this particular service state.
I mean, yes, it's possible. In this case, it doesn't. Well, it does remember a state. For example, you can say router deploy. That's a quite long command. So it will take. It's a valid command. It will try to package the entire this open source project, package it, and deploy to production to production's Artifactory. And that will take about like 15 minutes. So I just gave the command, and you will see how it's gonna perform it. And in the meantime, while the command will be running, I'll show you that there is some state. So the router actually, it keeps the state somewhere, persistence. Again, there's a database, like I showed you here. So there is a database, and look, this is the architecture of the system. So we have this service, and we have a database. So definitely we have a database where we keep the state, we keep the information of who is talking to me, why, what's the previous command, and everything. Like any other microservice. Yeah.
My question is about use cases. Do you know any systems, any other systems that can be built or already developed using this approach?
Yeah, I can give you another example. Again, I can give you my practical example. Maybe there are more. But let's say when we hire programmers, the programmers, they come to us and they fill a form on the website saying like, I would like to work with you, blah, blah, blah. There's some fields, and they click the button, and this whole form goes to another messaging system, not this one, but another system which we created. And this whole form is being posted there, and there's a message to the bot, a similar bot, which says, how about you find somebody who can interview this guy? And this system actually goes to the database, finds one of the programmers who can interview this person, and it posts a message to this, invites this person to this discussion, and says, how about you interview this person? That's another use case. So so we just automate the interaction of random people. But I think there, yeah.
Well, this architecture could be not partition tolerant, because the classical microservices, when one service is down, the whole system could be operational. But in this architecture, if message bus is down,
yeah, the message bus is a critical component. Yeah, if the message bus is down, the entire show is off. Of course, yeah, that's a valid concern. But compare the stability of GitHub and compare the stability of the system I can create. It's incomparable. So the GitHub is way more stable than anything I can create or you can create. It's a multi-million-dollar company. So it's better to rely on GitHub than to rely on any service we can buy. I think so. So that's my vision of that. So it's better to find, it's good to find some proper messaging platform like GitHub or Slack, for example, as well. Slack can also go down, but how often that will happen? Once a year. But yeah, definitely, the messaging hub is the critical point of failure. Yeah.
Reduction drawbacks. What I like here in your talk is maybe a list of drawbacks. And actually, one of the points which you made to me sounds like a clear compromise drawback. The number 4 was that errors are not easily visible. And to say that it's an advantage is to say that component that never throws exception is better than component that throws exception, because you don't see errors. So as a software developer, in my interest, of course, to see the error as soon as possible. And this is an advantage which I get from typical REST services. So I can rely on HTTP status code. I see here the scalability advantage of this asynchronous queued approach. But I definitely object by putting unavailability of errors instantly as an advantage. To me, it's a compromise which I might take because of other reasons, but I would never present it as an advantage of the system, that I can't see the errors immediately.
I got the question, it's a valid question, but we need to define what is I in all this. You just said I, but who is I? Is it
software developer?
Is it a software developer? But in this case, I think that when you say I, it means a user, not a software developer. Because when you say I want to see the problem, first of all the user will see it, not the developer.
No, I meant software developer, I didn't mean...
Yeah, I got it, yeah, you meant software developer, but for me it sounds like a user, because the amount of users is big, but the software developer is just, you know, a few people. And you're not using your microservice every second minute, you're just doing something else. But people and your users are actually using it and using it and using it, and they will be the first who will discover this exception. Well, in most cases that's how it happens. So basically that's a good approach for a web system. I'm also in favor of fail fast. I'm also in favor of showing exception and an error as soon as possible. I'm not hiding it. But in this case, it's just, we can just, what I'm doing, I'm just keeping an eye on the server, and as soon as the exception happens, I get an email. So I get an email as an administrator of this, and I have like this exception on my mail, and I can respond to it, and I can react. But the user doesn't see it. The user just sees no response, just nothing. So, but yeah, that's a valid question.
But just exception, just mention that to your microservice, to clients, to other services,
yeah,
post mostly in the same time some different messages,
yeah,
and your server answer like an error. But how do you notify to which message you responded error message?
Well, it depends on the protocol. It depends
just
on
for example, you can put two comments like merge and something else.
Yeah, you can. Yeah, it's a question of how to make them, to process them sequentially. We had this problem when I was designing the system. It was a problem. Like I can post a few commands, and this router will just process them. Like they'll try to answer them one by one, while still, for example, this command right now, the deploy, is still working. So it told me, I said deploy, and it said, okay, I'll try to deploy now, you can check the progress here. So now something is happening. So now the server, the Docker container is started, something is happening in this container, so it's deploying something. And we can check the status now, so I can say, router status. It can respond to me.
What if you put a merge comment before you get a response?
Internally, the router puts them in the line. So they will go one by one. So it will wait for the deploy to finish, and then the merge will happen. So I can post the router.
Actually, it depends on the implementation.
Yes.
Yeah.
You can do everything.
Yeah, of course. Yeah. It depends on the interface. So I designed it this way. You can try to design it differently. For example, on Slack, and you can respond to everything just in parallel. So design on the user case. In this case, it just, for us, it just doesn't work. You see, this is the response. So it says to me, I said router status, and it says this is what's going on here. The request number something processing command is deployed. Request has two parameters. There's some parameters. Build started 16 seconds ago. Build is running in this directory. Docker container ID is this. Working directory size is this. Server, the load average is this. So it gives me some snapshot of what's going on. Again, look, I can see, let's get back to the UI situation. I would be able to see this from the UI, right? To go to some panels, select, okay, this is my build. Click on the build, it'll open the window, I will see all the details. But do I need to design the UI for that? Do I need all these nicely good looking buttons and colors and everything which I have to maintain? Isn't it clear enough for a server administrator? It's clear enough, right, what's going on? It's just the text, which in most cases, this is like a comparison of a command line and graphic user interface. Professional users are still staying with command line. Probably some of you are doing the same, yeah. So I also like a command line, because in most cases, command line is way more effective than the graphic user interface. This is exactly the case. The command line is way more effective for simple microservices.
As soon as possible to pass parameters.
Yeah, you can pass parameters, yeah, of course. We do it like this. Router, for example,
we can deploy any branch.
Yeah, deploy some branch here. You can pass parameters. Yeah.
Could you please go back to slides? With question is about processes. For me, it looks like this approach works very well with asynchronous processes. When we ask our system to do something and we can wait for a while. And what about synchronous processes when you need to get the response immediately, when you need to maintain some consistency? For instance, you are selling tickets on a plane and you have limited amount of tickets.
Well, in this case, yeah, I understand the question. So sometimes you just don't want to drop a question and then just wait. So you need to close your transaction when that transaction is closed, right? So you're talking basically about transactions. In this case, you implement these transactions on your client side. So on the client, you just make a request and then you open this, you don't close the transaction, you keep calling, you keep asking me, do you have an answer? Do you have an answer for me? Do you have an answer? As soon as the answer is there, you close your transaction. But this is going to be responsibility of the client now. So you have to maintain this transaction atomicity on your side. But yeah, that's a valid constraint. Shut up. Who did that? You see? Somebody posted something out there, and rules are gonna respond now. Let's wait for that. I don't know who did that. Probably some of you guys. So this is the error from the deploy command. You see, it's posted a log. It says like I failed to deploy. This is the full log. You can hear something went wrong. I don't know what went wrong. There's something wrong. Connection timeout. And that's another command. Probably router is going to respond to that as well, because this is an unknown command. It will say that this command I don't understand. But let's see. You see, it's an open communication, and maybe this guy or somebody else. This is a bot as well, a chatbot. Maybe. I don't know. That's how they communicate. These chatbots can communicate with each other.
The question is about biggest. So how fast, from your experience using the GitHub, can be the request response for the synchronous scenarios?
Synchronous?
Yes. When
GitHub is fast. GitHub is fast, really fast.
So what's the overhead?
100 microseconds, milliseconds, 100 milliseconds for request, 100 milliseconds for request. It's quite fast. It's huge. Well, the problem with GitHub, I can tell you what the problems are. So there is some downside of that. So for example, GitHub, if you're going to make too many requests to GitHub, it's going to ban you for an hour, for example. So that's a concern. So GitHub, you have to deal with the GitHub somehow and negotiate with them. In this case, I emailed them before and explained them what's going on. They told me, okay guys, try it. And then I tried, and then it went over limit sometimes, and I emailed them again, and they increased the limit a little bit. So it's we need to discuss with the messaging hub. If it's your messaging hub, then you can do whatever you want. But if it's a big one like GitHub, then you have to respect their rules a little bit, or otherwise they're gonna walk you for. Yeah.
Is it possible to apply some kind of post-commit hooks instead of pulling per minute?
Yeah, it's possible. There are two approaches actually. You can do commits, but for the hooks, the problem with GitHub for the hooks, then everybody who wants to use this service will have to first of all configure the hook. But in this case, we don't need to configure anything. You just start a project in GitHub, you just open the ticket, you just post something there, and immediately this chatbot will immediately catch this request.
It also works in pull requests, right?
Yes. On pull request everywhere, yeah. Pull request everywhere. I don't know, 2 minutes, I don't know why it's not answering. You see, but we don't see the problem here, right? Just no answer. Maybe there's my phone is switched off, but maybe there's an email there that something went wrong and you need to check something, but the user doesn't experience any problems. So just a delay, just 2 minutes, but it's supposed to be 1 minute. It's already 2 minutes, so maybe there's internet problem. No, still no answer. 3 minutes. Yeah, we can check the status. So we have a panel. We have a small panel for the system, which just one page which shows what's going on with Router, and it says that everything is fine. Let's try. Let's speak. Let's say hello. I don't know why. Maybe there's a bug or something. But the system says, look, this is the diagram which you see it changes like it's here. It shows every line, it's a request at GitHub. So So every green line is when the router goes to GitHub, and this is the width of the line means how much time it spent there. So it just goes to GitHub, spends like 3 seconds, and disconnects. Again, it goes to every minute, every minute. You see, so this is the time of how much time since the last session with GitHub. So you see, it's on respond there. You see, it's, for some reason it answered to this message, but it didn't answer to the shutdown.
Yeah, maybe it's bot.
No, it doesn't matter. It has to be answered.
He's working.
See?
And maybe he don't like him, so.
I don't know. Let's see.
It's not fun or
No, it should work. But anyway, if it, you see, this is just an illustration of what the bug means and how it's. So do we have time more? A few minutes, right?
how can it be scalable? Or if it's appeared too many requests?
It can be scalable to no limits. It actually can be scaled to no limits, like I showed here. So you can create as many machines on the server side, on your side, on the server side. They can talk to GitHub as much as they want. The only problem is that the GitHub, in the case of GitHub, is going to ban you if there's too much traffic. So if you want to do it like on a high load, then you should use something else, not the GitHub. But in general, the idea is very scalable. So you can scale up to no limits. Okay, I think that's it. Thank you very much.